Hi. In this section, we're going to take quantitative data and organize them with histograms, a frequency polygon, and a time series graph. And so we're going to do an example with frequencies and also frequencies with class intervals. Okay, so let's take a look at the first example. So a histogram is similar to a bar graph, but it's for quantitative data. And histograms have a horizontal and vertical axis, right? Where horizontal axis lists the values in the frequency table, and the vertical axis lists the frequencies. So it's the same as a bar graph, except instead of categories on the x-axis, we just have those pieces of data. And then rectangular bars are touching the adjacent bars. So notice that histograms, we are allowed to touch them because you have discrete and continuous data, right? Not categories. Okay, so below are a random of 16 selected weights of models from a model agency. Construct the histogram from the data. So notice here there's only 16, so we were able just to write these 6 different weights down and have frequencies for each of those weights in pounds of the models. So let's go ahead and draw the first quadrant. Okay. And so now what we do is we're going to label the x-axis the weight, which is in pounds. And so we would have 85, 98, 100, 110, 115, and 138. And then here we would have the frequencies. And notice that the frequencies will be the y-axis. It would be the number of models that are that certain weight, right? It would be that 2 models weigh 98 pounds, 4 models weigh 110 pounds. So we would have frequencies on the y-axis. And then how should we label the y-axis? Should I go to 100 frequencies? No, we only have the highest number of frequencies in any one of the categories. It looks like it's 4. So maybe I should just go up to 4, right? 1, 2, 3, 4. Okay, so that's what that looks like. And now that we have these little tick marks here, again, we're going to draw the rectangle around, and this time we'll have the bars touching. So let me grab a color. And that color is going to be blue, and then 4 models weigh 85 pounds. So let's go ahead and do that. Um, 2 models weigh 98 pounds. So we'll go ahead and draw that. One model weighs 100 pounds. There. And then 4 models weigh 110 pounds. So you could see mine's not perfect because it's just hard to draw them. And then 115 is 3 models. Okay. Okay. And then the last one is only 2 models, so I'll just go ahead and draw the bar. Perfect. Okay, and then if you wanted, you could always do like little shading to make it look nice. And then what you can also do is put the number of frequencies on top of each bar. So this would be 4, 2, 1, 4, 3, 2. So it looks like that. And that's essentially what that's all there is to a histogram, right? Rarely do we draw these if we have 1,000 pieces of data. No, we don't. We have a computer generating graphs for us and everything. But again, it's very mathematical in how we conduct these histograms because um, that's part of this class is to show you the math part behind these graphs and how they're derived not just from pictures you see on the internet, but mathematically constructed. And then they were developed into algorithms and into software, and then now we get to just have it at within a few seconds. So the next part would be to show you that part of technology. So why don't we go into our calculators and enter this data information about with the model and weights and see how fast your calculator can calculate that. So let's go ahead and do that. Okay, so I'm using a TI SmartView TI-84 CE calculator, and we're going to go ahead and graph the histogram on this calculator. So the first thing you'll want to do is go to y equals right here and make sure there's nothing plotted, and you could see that I do. So let me go ahead and clear that out and I'll hit enter. So I want to make sure all these are clear because it can get, when you start graphing in stat mode, it gets kind of weird. So at this point now, I'll just go to the home screen and I see everything's clear, and then I hit stat. And now I'll go to edit because I want to put this data in a list. For the model weights, 85 and frequency, we can kind of see like this is the weights are one column and the frequency is another column. So let's make it look the same here. Let's put the weights in one column on the right side and the frequencies on the other. Okay, almost done. And then list 2, move the cursor over, go ahead and put the frequencies in that column. So it just mimics what you see on your paper versus what's in the calculator. So you can see they look identical, right? Okay, and now what we can do is go to stat plot. So notice right above the y equals, you'll see like a blue stat plot, blue, 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 and then you'll start to notice blue everywhere on top of the buttons. So blue with blue. If you want the word quit, then you hit blue with blue, second quit. If you want the green part, which here are the alphabet letters, and the functions up here, then hit green with green, alpha with the green. So in our case, we're going to hit second stat plot because that's blue with blue. So second y equals gives me stat plots. Notice I hit number 1 is highlighted and it says off, but just go ahead and hit enter. It'll take you into a new menu. And now it comes up with all this cool stuff, right? So let's go ahead and turn it on. Okay, hit enter. Now move on to the type. Notice you have some dots, some lines, some bars, and some of all this other stuff, right? But notice the bars is the one we want, right? We wanted the histogram. So let's move the cursor over to the right and then hit enter. Go down. My X list, meaning my far left list, is the weights, right? Which was list 1. And the frequencies, remember, were that second list we had on the right side. So that would be list 2. So if you notice on your number 2 digit on your calculator, above in blue is L2. That's your list 2, blue with blue. Hit second 2, which will give you the L2. Okay, my favorite color is blue, but one thing I love about this calculator is you could choose any color you want. It has a whole bunch. And so I usually just choose blue because I love blue. Now don't hit graph so fast because your graph is going to be like in algebra mode. So let's go ahead and graph it with the stat window. So you're going to go to zoom here and then hit number 9, which is zoom stat. And that's not there for... So go ahead and hit 9. And notice it gives you this histogram. Now it doesn't look like our histogram because notice our tick marks are a little different. So what we could do is move the cursor along, hit trace, And we can see that this would be minimum is 85 and the max is 96. This bar would be the minimum is 95.6 and 100.6.2, right? And that's 3. So you could see, if you move the cursor more, you could see the intervals in which the histogram lies. And it's doing that because it's trying to make the intervals equal. We could see that the weight difference between 100 and 98 is 2 pounds, but the difference between 98 and 85 pounds is 13 pounds. So they just want the tick marks to have equal marks in the calculator. We just kind of did one with just the weights given because it's just an introduction where you don't have to be so tedious, because again, we're going to always use technology to construct our histograms. But it's just to show you that your calculator can do these in technology really fast. And that's really what it's there to show you. And if you wanted to do a histogram in your calculator, that's fine too. But just know that when we read the histograms, the height is always the frequency, and the x-axis is always the category or the values in your quantitative data and your frequency table. Okay, and what are the two things that we know about with histograms versus bar charts? Well, we do know, let's just make sure we know this is for now quantitative data. Is on the x-axis and bars touch. Okay, so those are the main two things. If they don't touch, we assume categorical data. If they touch, we assume quantitative data. Okay, and you can see that what we just did in the calculator is all here. So. Okay, well, what about those class intervals, right? Let's go back to the textbooks, right? So I went ahead and put one in, an example with textbooks and class intervals. So let's go ahead and do that. And don't worry, we don't have to do the frequency table again. I have the midpoints and the frequency there with the classes. So all we're going to do is really label and draw the bars. So let's go ahead and do that. So what should we do on the cost? Well, with class intervals, we always have the lower limits. So there's you either can use midpoints or lower limits. So here are the lower limits, right? Let me go ahead and highlight. So we can go ahead and write those on the tick marks. We could also use midpoints. So it's really up to you and the reader. So you use midpoints on x-axis, or you can use lower limits. We used the midpoints already for the frequency polygon in the previous section. So now let's do this one using lower limits. So that way you have both and you could see both. But you can feel free to do mid classes if you like, and draw rectangles around the midpoints, or use lower limits and draw rectangles from tick mark to tick mark. So let's go ahead and do lower limits here. Okay, so if I go ahead and do lower limits, I'll put 140 here, 180, 220, 260, 300, 340, 380, and 420. And of course, we can always fill those other tick marks that are out of the scope of our data as 100 and 460. Okay, and then now what about our frequencies? Well, the largest number of frequencies for any category was 10. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe we can do frequencies by 2. So we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, great. All right, and then now let's go ahead and draw our bars. So we can draw our bars easily. Since we're using lower limits, let me do this in a different color. If you use lower limits, then you're going to draw tick mark to tick mark. Okay, if you use midpoints, you're going to draw around the midpoint. So we're going to draw tick to tick. So from 140 to 179, we had a frequency of 4. So here's 4. Okay. From 180 to 219, we had 1. From 220 to 259, we had 4. $260 to $299, 6. $300 to $339, 10. And go ahead and fill in the rest while I do mine. Okay, and you can shade them or write the frequencies on top. Like here would be 414, 6, 10, 6, 2, 3. And that's all there really is to it. So no matter what, if you're using frequency tables without classes or with classes, you can always just use the lower limits and draw tick mark to tick mark. If you use midpoints, you'll draw around the midpoint in the same manner that we drew around the values of weights for the models. So these would be like midpoints if we had class intervals, because we would be drawing around the tick mark. In class intervals, if you wanted to draw the histogram using lower limits, then you would draw tick to tick. So it's really just up to the student, and it's really just preference. That's all. Yeah, and then the only thing is you just want to check with the textbook and your instructor for how they're going to do it. If they're going to test you on it, are they going to use lower limits or midpoints? And just kind of verify that with the instructor. I usually accept both, so I don't really care. So as long as you understand that histograms are quantitative data and bars touch, I think that's more important to see the differences in the graphs and the type of data we use. So the last thing is, let's go ahead and talk about a time series plot. And a time series plot is exactly what you would think. It's time, series, and a graph. So any data that has time attached to it, we call it a time series graph. So the x-axis is going to be the time, right? Yeah. And then the y-axis would just be the frequency. So in this case, we have some data of CO2 emissions in the US from years 2003 to 2009. Here is our frequency table. So a frequency time graph, so a time series graph is going to have the time on the x-axis and the frequency on the y-axis. So notice these are in millions. So instead of having numbers out to here, they just did it in millions and rounded to the nearest tenths place or 100,000th place. So notice that the time series is actually a line graph. Notice it's not a polygon. It doesn't close off at the ends. So it's just a line graph that connects from year to year or time frame to time frame with its frequencies in chronological order. And also being organized in a frequency table. So those are the two types of graphs that we see for time, data with time in it.